solving systems of equations using Cramer's rule. So let me show you how this is derived. So if I have ax plus by equals e, this is just a linear equation, right? And another linear equation. If I were to solve this system, what would I be finding? No. X and y. What am I finding? The coordinates. Where are they what? Where they intersect. That's what I'm finding. Okay? So, if we were to use elimination, I could find x by, first of all, multiplying the first equation by d. See how they did that? This one, top one right here, multiplied by d. The second one is multiplied by b. See that? The third thing that you do is subtract them. Then they both have an x in common, so I would factor. And then finally divide. And this is what you get. So, check this out. Look at DE and BF. Do you see DE and BF up here? That wasn't very good. What's that look like? The determinant, right? And what about this one down here? It's A, C, B, D, right? Do you see it? Okay, so let's work off that. Yes, Evan. You're going to see right now. Okay, so real generic, the solution of the system of linear equations, the same thing I just showed you, is, check this out. If I want to find x, I would take the constant that is equal to the third column right here and cover up my x's. E, B, F, D. E, B, F, D. See that? If I want to find x, I would take the constants here and cover up my x column. E, B, F, D. E, B, F, D. See it? What do you think I'm going to do when I want my y's? Cover the other one. You got to cover up the positive and the negative, the whole thing. I'm going to expand it. A, E, C, F. A, E, C, F. See it? And to get the denominator, you just eliminate it. A, B, C, D. A, B, C, D. That's what we're going to do. What? It's not that bad. Okay. So let's start with one. This is number one on your homework. So the first thing I'm going to do is cover up. Oh, you'll see. It's a worksheet. Okay, so if I want to find x, I know it's a fraction with matrices in the numerator and the denominator, and y equals all right, so what goes here? 6, 3, -2, 1, and here 2, 2, 6, -2, and in the denominator I just do these four right here, right? 2, 3, 2, 1, and they're both the same. The denominator is always the same. 2, 3, 2, 1. All right, so I'm going to simplify that. This would be 6 minus 6, or 6 minus negative 6, which becomes 6 plus 6, over 2 times 1 is 2, 2 times 3 is 6, minus 6. 2 times negative 2 is negative 4, minus 12. Is that correct? Over, this is the same thing, right? Negative 4. I don't have to do it again. I already did it. Correct? So I get 12 over negative 4, which is what? Negative 3. And negative 16 over negative 4, which is? 4. Positive 4. So my solution is negative 3 comma 4. Make sure you get that down. One. Okay, so why don't you guys do this one? Okay, I'm going to show you another method. You ready? Okay. So, I know I have, hold on guys, just watch me and I will give you time. I have another way for you to do this. Just yanked it out of his hand. Can't write if you don't have a pencil in your hand, right? Are you that eager to get started? Okay, check this out. I can also do this. The 2 and the 3 is supposed to go in the X spot right here, right? And over here it's supposed to go in the Y spot. And here it doesn't go at all. Does that make sense? That way you can see, oh, I can't even write there because it's already taken. Does that make sense? Okay, so what goes here? 1 and negative 1, and what goes here? 3 and 2, and what goes here? 3, 2, 1, negative 1, 3, 2, 1, negative 1. Now do it. So you should have gotten 1, negative 1. Questions on this? For those of you that aren't done, I'll give you a second to finish. Done. Okay, check it out. Ready? Okay, I don't think you should write it, guys. This is one of those things that you just watch me do it. You have 3 more to do on your own, so. All right, so I don't know why, but this says C. It should be E. Okay, so let's start with C. I'm gonna color code this stuff. So C equals and D equals, I'm not even going to do the whole problem. You'll see why. Somebody time me and see how long. It's right here. It's 8 minutes right now. Let's see how long this problem takes me to do. What? Not at all. Case. Right? Okay. So, just like the last one, how I showed you 4, negative 3, 0, if I want to find C, I should put that there, right? 4, negative 3, 0, 4, negative 3, 0, 4, negative 3, 0. Then this one would be negative 5, negative 3, 2, 2, 4, 3. Thank you. No. You take the coefficient. That coefficient is negative 2, negative 3, and negative 5. Okay, this one is 3, 2, and 4, 2, 4, and 3. And this one is 3, 2, and 4, negative 5, negative 3, negative 2. And the denominator is 3, 2, 4, negative 5, negative 3, negative 2, 2, 4, 3. I'm getting tired of listening to myself. Let's just copy it. Right? Thank you. What? I would, like if I have a sub and it's not Miss Watkins, I would do that. Okay. So now what? What do I do with this? I got to expand it. So you have 4 expansions to do here.
Wait, how many?
See why I'm complaining? Okay. Okay, so which would be the easiest row to expand? The bottom. So I'm going to highlight that one. We're going to expand this one. When I expand it, so this is just C. That's all we're doing right now. It would be 0, right, times something, minus -2, which would be makes this +2, right? And then 3. I sure can. -2. Yep, makes sense. Okay, so on the 0, I would cover up this one and this one, correct? So -5 to -3, 4. Then just move it, right, to the middle. 4, -3, 2, 4. 4, -3, -5, -3. All right, so I also suggest, we're not done with it. That's just the numerator of C. Yeah, you can, that's why you have to do all these are the same. Okay, so I would keep all of my work here because you may get duplicates when you're getting all these rows and stuff. So 0 times, I know it's 0, but what would it be? It would be -20 plus 6, so -14. This would be, what? What, did you hear what I just said? I'm going to write it in there because you can, sometimes when you're doing the other expansions, you'll have a -5 to -3, 4. So you already have that answer in there. But yes, it is just 0. Plus 16 plus 6, 22. So plus 2 times 22. And 12, -12 plus 15. -12 minus 15 is -27. So plus 3 times -27. Is that right? Equals? Yes. What do you mean what happens? Why are you asking me questions right in the middle of me doing it? What do you mean what happens to the denominator? Okay, we're moving on. See, when you do stuff like that, Evan, you're like, everybody's like thinking and their brain is processing right now, and then all of a sudden, stop! Why are you, we're not even on the denominator. Why are we talking about the denominator? We're not there yet. Okay. What is this? Somebody put this in a calculator.
I didn't think fit to the calculator. We're free.
Anybody? Yes? -37. Thank you. Okay. So that's the numerator. That's this right here. Let's find the denominator now. Yes.
Can you choose any number when you're doing the...
Yeah, remember that was our discussion when we first started? You can use any row. It has to be a row. No. You have to use a row.
And you can use like the bottom row on C, and you don't have to do the bottom row.
No. It could be any row. I'm going to use the bottom rows just to be consistent. Okay? You don't have to be consistent. So I'm going to use this one. So this is my denominator. Let me change my color. Let's use green. Okay, denominator is 4. Isn't it helpful to like do the framework first, right? Minus, as Evan wants me to do, -2. It's a good idea, Evan. No. I don't want to spend class time to do the whole problem. Okay. So, go ahead and cover these up. What am I doing? Wrong tool. That's what I'm saying. So this would be -5 to -3, 4. And just like Evan says, it's that one. Same thing. And take and move this to the middle. And get 3, 2, 2, 4. Move it again. And you get 3, 2, -5, -3. 4 times -20 minus -6. -14. Oh, why am I doing it? I already did it. That was dumb. This is +2. Do I have anything that looks like that? No? Okay. Oh, well. 4 times 3 is 12. 12 minus 4, 8. And -9 minus 10 is 1. Correct? So what do I get? What's 4 times -14? -56 plus 16 plus 3. What's that? -37 is the denominator. So C, you guys ready for this? C is 1. Next! Evan.
This might be going a little bit, but once you find 2 of them, can't you just put those both in numbers and see if there's any time left?
Say it again.
Once you find the first couple, can't you just get those 2 and plug it into the first one of the equations and then find the last?
Oh, you can't do that. You could do it once you could do it once you have 2 of them. To find the third one.
That's what I meant.
Yes. Absolutely.
That means you don't have to do all of it.
So we found one of them. Now you just have to do one more,
Yeah, and then put
because then you already know the denominator of this one.
Make sure you don't bring that up to.
I won't.
Check on you.
So it's 1, 2, 3 that you have to do for one of these? Okay. Should we finish it up then? So I'm going to go ahead and stop there. My other class didn't get to hear, but what did you learn today? Cramer's rule. What do we use Cramer's rule for? What? Not just expand. What are we doing? We are solving a system of equations. Explain in your own words the process of setting up a matrix using Cramer's rule. That's what those, and I'll get you those back in just a second. Good job, guys.